Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 7.3, Solving Systems by Elimination, Day 2. Example, sometimes we must multiply one or both of the equations to make opposite coefficients. Remember yesterday we talked about in order to use the elimination method, I have to have opposite coefficients, which means that if I have, say, a positive 15y, then I need to make my opposite y negative 15, right? Well, that's exactly what we're going to have to do here in our first example. I'm going to look for the easiest way to make one of my coefficients into the opposite of the same variable on the opposite or the other equation, right? So is negative 2, is it very, very easy to get negative 2 to equal 7? You could multiply by 3.5, but that really is going to make things a little tricky. But negative 5y, turning that into a negative 15y would be pretty easy. What I would have to do there is multiply that negative 5 by 3. Well, if I do not want to change my equation, which I do not want to do, as far as the value, what I would have to do then is multiply everything by 3. So this would turn into 21x minus 15y equals 17. Not 17, I'm sorry. That would equal 51. Okay? So what I'm going to do now is I'm going to add these two equations together. Okay? So negative 2x plus 21x would get me 19x. Positive 15y minus 15y would get me 0y. Negative 32 plus 51 will get me positive 19. If I divide by 19 on both sides, then I can solve for my x. So x would equal 1. Now what I need to do is take the 1 and plug it in for x in one of my two original equations. Do not use the equation that says 21x equals 15y equals 51. Or minus 15y equals 51. Either use negative 2x plus 15y equals negative 32, or use 7x minus 5y equals 17. Well, I would like to divide by the smallest number possible. So because that's the case, I'm not going to mess around with this 15y equation because I would have to divide by 15 at some point. I'm going to go ahead and plug it into the 7x minus 5y. So if I do that, I would have 7 times 1, because my x did equal 1, minus 5y will equal 17. Well, 7 times 1 is 7, minus 5y would equal 17. I need to subtract my 7 from both sides. Negative 5y would equal 10. Divide by negative 5. So y would equal negative 2. So my coordinate would be 1, comma, negative 2. All right? On to example 2. I have 2x plus 5y equals negative 22, or I have 10x and I have 10x plus 3y equals positive 22. It's really, really easy to get from 2x to 10x, right? I'd multiply by 5, but I need it to be opposite. So what I'm going to do is multiply my first equation by negative 5. If I do that, I would have negative 10x minus 25y would equal positive, because, I don't have to put a plus sign. Negative 5 times negative 22 would get me positive 110. Positive 10 minus 10 would be 0. Positive 3 minus 25y would get me negative 22y. 22 plus 110 would get me 132. Now if I divide by negative 22, I end up with y equals negative 6. Now I need to take the negative 6, plug it back into my equation. Remember, I'm going to use, personally, I like to use the equation that has the smaller coefficient on my opposite x or y. So in this case, I'm going to use my top equation because it has a smaller coefficient of 2x. So I'll have 2x plus 5 times negative 6 equals negative 22. 2x, 5 times negative 6 would be negative 30, equals negative 22. Add 30 to both sides. So 2x would equal positive 8. Divide by 2. X would equal 4. So my coordinate then would be 4, comma, negative 6. And we're good to go. On to number 3. This is one where I cannot just with one multiplication get us to the opposite coefficient of our x or our y. So what I'm going to do now is look and see if my x or my y has two coefficients that are smaller than the other two. Well, in this case, I have 3x and 2x, which are both smaller than my 4y and my 5y, right? So what I'm going to do in order to make this the opposites, right, and opposite coefficients, I'm going to multiply my top by the coefficient for my other equation, so positive 2. Now, if I multiply the bottom by positive 3, I'm not going to have opposite coefficients. I'm going to have the same coefficient. So I need to multiply by negative 3 in order to get opposite coefficients, right? So 2 times 3x would get me positive 6x. 2 times 4y would get me positive 8y. 2 times 5 would get me positive 10. Negative 3 times 2x would get me negative 6x. Negative 3 times positive 5y would get me negative 15y. Negative 3 times 1 would get me negative 3. The 6x and the negative 6x would cancel. So I'd have 8 minus 15, which would be negative 7y, will equal 10 minus 3 is positive 7. Divide by negative 7. Y would equal negative 1. Now I need to go ahead and put that back into one of my equations. Again, I'm going to use the 2x plus 5y because the 2 is smaller than the 3 for my leading coefficient. So it'd be 2x plus 5 times negative 1 will equal positive 1. So 2x would minus 5 would equal 1. Add 5 to both sides. 2x would equal 6. Divide by 2. X would equal 3. So my coordinate would be 3, comma, negative 1. Finally, this last piece, I already have this set up. If you look at this pretty closely, what you could possibly do is just go ahead and divide everything by 3, and you could use the substitution method. We're not going to do that right now, but that's something you need to recognize. If I'm really, really close to having an x or a y by itself completely, then think substitution. But we want to keep practicing our elimination, so I'm going to subtract the y from both sides. So 3x minus y will equal positive 27. Okay. Now I'm going to add this equation and this equation together. Or I can't do that yet, I'm sorry. But I'm going to look at those two equations. So I have 3x minus y equals 27 and negative x plus 8y equals negative 32. I can make this very easily turn that negative x into a negative 3x by multiplying by 3. So negative 3x plus 24y would equal negative 96. Okay. The 3x and the negative 3x would cancel. Negative y plus 24y would get me positive 23y. 27 minus 96 would get me negative 69. If I divide that by 23 on both sides, y would equal negative 3. Okay. Now again, I want to use the smallest coefficient personally. That's just my preference. You could put this back into any of these. Actually, in this case though, I have the 3x by itself already. So it'd be pretty simple to just take my negative 3 and plug it back into this equation for my y. And that's what I'm going to do. 3x equals, my negative 3 goes in for my y, plus 27. 3x would equal, negative 3 plus 27 is 24. Divide by 3. X would equal 8, so 8, comma, negative 3. Okay. On to a story problem. Now that we've got our practice in with elimination, having to multiply, sometimes having to double multiply, let's move on to problem 7. It's a story problem, not overly difficult. You just need to pick out the important pieces, okay? Suppose your class sells gift wrap for $4 per package and greeting cards for $10 per package. Your class sells 205 packages in all and receives a total of $1,084. Find the number of packages of gift wrap and the number of packages of greeting cards sold. First thing I want to do is make my variables. So it's the packages of gift wrap and the number of packages of greeting cards sold. I'm going to use W for gift wrap, and I'm going to use C for greeting cards. Okay. Well, it's asking us to find the number of packages of each sold. So it has given us this information about 205 packages in total. Well, what I can do with that is use W plus C to equal 205, right? Then it also told us that it's $1,084 is how much they sold in total. So I need to use the $4 per package of gift wrap, okay? So it would be 4W plus the $10 per package of greeting cards, so plus 10C would equal our 1,084. Now I have two equations. What I need to do is go ahead and use my elimination method. So I'm going to multiply the top equation by -4 because my bottom equation has a positive 4, right? So I'd have -4W minus 4C equals -820. The 4W's would cancel, so it's positive 10C minus 4C, so it would be 6C, is equal to 1,084 minus 820 would get me 264. So I would have to divide by 6 on both sides. So C would equal 44. So I have 44 greeting cards, right? Now that I know how many greeting cards I have, I can plug it back into our W plus C equals 205 to find out how many packages of gift wrap I sold. So it would be W plus the 44 cards equals 205 total minus the 44. So the packages of gift wrap I had were 161. I'm just going to put wrap. And those are our answers. Okay? On to the last story problem. On a special day, tickets for the Quad City Swing cost $5 for adults and $1 for students. The attendance for the day was 1,139 and $3,067 was collected. Write and solve a system of equations to find the number of adults and the number of students that attended the game. This is exactly like what we just did. So I'm going to use A for the number of adults. I'm going to use S for the number of students. So I'm going to add the adult tickets and the student tickets total. The attendance was 1139. Now I need the price of the adult tickets is 5, so 5A, plus the price of the student tickets was $1, so it would just be S, is equal to the total amount they collected, which is $30.67. Now what's going to happen here is I will need to multiply one of my two equations by something in order to get the opposite coefficient, right? So if I multiply my top by -1, I would end up with -A minus S is equal to -1139, right? So now that I have have my new equation, what I can do is take 5A minus A, which would get me 4A. The positive S and negative S will cancel. So then I have 3,067 minus 1139, which is 1928. I'm going to take both of these and divide by 4. So the number of adult tickets I have is going to be 482. So I have 482 adult tickets. Now I'm going to plug that back into my A plus S equation. So my A is 482 plus S would equal the 1,139 tickets sold. If I subtract the 482, I would have the number of student tickets is 657 students. All right. Well, that is the end of the lesson. Remember that when you have the elimination method is something that you want to use, you have to make sure that you have the opposite coefficient in the two equations. And sometimes you're going to have to multiply by a given number. If you multiply by a given number, remember just to multiply it all the way through the equation, not just to the variable you are trying to make opposite coefficients with. Once you do that, you can use the elimination method just like we learned in our last section. If you are struggling with any part of this, please make sure you come and see me. do not be confused by what you're trying to do. Otherwise, thank you very much for watching the video, and have a great day.